This video summarizes an EMI investigation performed at an LTE700 site. Unexpected RF signals was observed within an LTE channel, and the goal was to determine whether this energy was simply analyzer noise or real external interference that could impact system performance. The following sections walk through the measurement setup, noise floor reference, measured interference, and an EMC interpretation. Measurements were conducted at an LTE700 site using a direction antenna, the model number showing on the screen, which provides approximately 7 dBi gain. The RF cable between the antenna and the spectrum analyzer introduces roughly 1 dB loss. All measurements were performed using a 9 MHz bandwidth to match a typical LTE channel, ensuring results are optionally relevant. Before measuring over-the-air signals, a reference noise floor was established. The antenna was replaced with a dummy node, while keeping all analyzer settings unchanged. Refer to trace A, marked with M1. In 9 MHz bandwidth, the measured noise power was approximately -93 dBm. The value represents the baseline sensitivity of the measurement system. With the antenna reconnected and using the same analyzer configuration, a significant increase in received power was observed within the 9 MHz LTE channel, actually in the whole frequency range. The measured power was approximately -50 dBm in 9 MHz channel bandwidth. This large increase compared to the noise floor strongly suggests the presence of real external RF energy. In this case, the LTE base station was installed on a building rooftop, which is very common in dense urban deployments. During the site survey, we identified nearby CATV infrastructure on the same rooftop. Some of the CATV cables were unterminated, meaning they were not properly shielded or matched. These unterminated CATV cables effectively behaved like antennas, unintentionally radiating energy into the LTE700 band. This radiated energy raised the receiver noise floor and then showed up in our interference measurements, even though the LTE system itself was operating correctly. So, the key takeaway here is that the interference was external, coming from nearby infrastructure, not from the LTE equipment or configuration. Refer to noise floor reference section and record the noise floor with preamplifier off is -78.5 dBm in 9 MHz bandwidth. Comparing the two measurements directly shows a difference of approximately 28.5 dB. This margin is far beyond any reasonable measurement uncertainty and then confirms that the observed signal is not analyzer noise, it's a real external interference signal captured by the antenna. When antenna gain and cable loss are considered, the received signal remains very strong for an unintended emission in a licensed LTE band. At 700 MHz, signals propagate efficiently over long distances, making systems particularly sensitive to interference. Such signals can raise the effective noise floor at the receiver and then degrade overall system performance. From an EMC perspective, this case highlights that interference is often broadband rather than discrete tones. Measuring over the correct bandwidth, in this case, the LTE channel bandwidth, is essential for meaningful interpretation. Field measurements like this provide critical insight into real-world EMI risks that may not be apparent in lab testing. In summary, establishing a proper noise floor reference is the foundation of any credible EMI investigation. A 28.5 dB margin between noise and the measured signal clearly confirms the presence of real interference. Finally, EMI measurements must always be interpreted in context, including bandwidth, antenna characteristics, and system impact, to support sound engineering decisions.